Hi team, my name is Ayushman Dubey. I'm a BTech graduate and I am pursuing full stack data science course in Alma Better. This is my second capstone project which I conducted on bike sharing demand prediction. The project type is regression. I individually created this project. So summary of this project is the companies like Bird, Capital Bike Share and City Bikes. They faces the challenges during the rental bikes. Uh, mm, Having too many bikes can result in resource wastage, including bike maintenance and parking space. And while having few bikes can lead to the revenue loss. So this project just predict the demand of their service on any given day. The aim of this project is to address the challenges, the combining historical bike usage pattern, which was already happened and which is the provided by the companies, the history, the data set of these companies, like the weather data to forecast the bike rental demand. In the dataset which was provided to me, that dataset contains the variables like seasons, holidays, functional day, rainfall, snowfall, rented by count. I have used Python, NumPy, Seaborn, and Scikit libraries to develop the algorithms and to predict the models and uh, to visualize the data. In order to, it is not worth nothing that potential benefits of accurate bike rental demanding forecasting. This technology could help the other companies to reduce the waste and improve their resource allocation. And this project will help to them who are in the field of bike and scooter ride sharing services. Uh, Environmentally friendly alternatives I can provide in this project. Overall, this project predicts about the demand of bike rental sharing. So this is my GitHub link. So what was the problem statement given by the company that currently rental bikes are introduced in many urban cities for the enhancement of mobility comfort. It is important to make the rental bike available and accessible to the public at the right time as it lessens the waiting time. Eventually, providing the city with a stable supply of rental bikes becomes a major concern. The crucial part is the prediction of bike count required at the each hour of the stable supply of rental bikes. So these are the data set attributes of data set which I got in my data, that like date, hour, temperature, humidity, wind speed, visibility, solar radiation, rainfall, snowfall. So first I imported all the required libraries which were required to proceed in my project to apply the machine learning module to visualize the data, to frame the data frame. Then I imported then I mounted my Google Drive with the Google Colab notebook. Then I loaded the CO bike data, a common separated valuable file, which was my data set. This is the head of the data set, top five rows of my data set. This is using tail function. I have displayed the bottom five rows of my data set. This is the shape of my data set, having 8760 rows and having 14 columns. The reason behind 8760 rows is a year consists 8760 hours in a year, means 24 hours in a day, and year consists of 365 days. So 365, if we will multiply 365 with the 24, we will get the number 8760. Next, what dataset column counts. So we are having 14 columns. Here is the name of the those columns. Now the next was is the description of my data set, like bike rented count maximum is 3556, humidity is 98%, visibility is 2000, rainfall is 35 mm. Now the unique values of my data set, like date 365 days, date are 24 hours in a day. Seasons, four seasons are there: winter, autumn, summer, and spring. Holiday, two holidays are there: Saturday and Sunday. Function day. Next is, this is my data set info, data frame info. I have named that data set as a bike DF, bike data frame. This is the type of my all the variables. All are non-null values. Then I checked for the duplicate values, there whether any duplicate values is present in my data set or not. So I got the result that no duplicate values are present in my data set, and no missing or null values are present in my data set. So here is a visualization about the percent of missing values. These are the variables and this is the percentage. All the variables are at zero, means no missing values present in my data set. That is a very good thing about this data set. Then some complex name were there, complex variable name were there, like temperature was in degrees Celsius, humidity was in percentage. So I converted all the names, complex name into the simple name like temperature Celsius into temperature, visibility 10 mm into visibility, humidity percentage into humidity. So this was my 8760 rows and 14 columns. Then I broke down the date column into three parts, like year, month, and day. The reason behind it, because Python can read the date as a object type, which is a string, and I do not want to want this to be happen, because it will difficult to means in the next analysis it will be difficult to visualize the data on the basis of date. Next, this is the head of my data frame, information about my data frame. Next, weekdays and weekend. We have the 104 Saturdays and Sunday in a year. If you multiply 104 with the 24, we will get this value 2496. And if we subtract 365 with 104, we will get 261. 261 into 24, 6264. If we will add these two values, we will get 8760, which is the uh, a year consists of 8760 hours, which is the sum of these two values is 8760. Next is the detailed description of my data frame. These are the variables, checking the unique values. Now changing the data types like hours, month, weekdays into the category, so that I can do the categorical analysis and numerical analysis. Next, this is the columns. Now, from here, I'm starting my analysis, exploratory data analysis on my data set. First, I compared the two values, month and rented bike. What I got the answer, like from May to October, the highest demand of bike rentals are there. Next, a prediction, comparison about workday and non-workday. What I got from this one, that bikes are it is evident that people do not use rented bike on non-functional day. People are using rented bikes on working day. If they want to go to if office, they want to return from their office, they are using the rental bikes, like for the hours. So they are using in the morning 7 to 9, and they are using from in the evening 5 to 7, which is a time to going, which is a time, this is a time going to office, and this is a time going to returning from office. Next is weekdays and weekend. So the comparison of weekdays and weekends. So what I got the answer as in, however, we know about the weekdays, that 7 to 9 and 5 to 7. But what about the weekends? So what answer I got, at the time of 4 to 8, the demand is slightly increasing. However, people are not renting the bike on weekends. Now, according to the season, winter has the least amount of rental bikes in the uh, uh, as compared to summer. Summer has the maximum amount of rental bikes, reaching the amount of 1,000 here. Next, next is holiday. Whether it is holiday present or not, so bikes are more rented on the no holiday, a day which is not termed as holiday, or which is not declared as holiday. So people are tends to rent it between 2 to 8 on the holiday session. Now analyzing the numerical variables. So here you can see a graph between density and rainfall. Next, a dark graph between density and snowfall. Here it is 0. You can see here. Here it is. The peak is on again 2 and 0. Next, for the rented bike count. So here you can see on the value of 1000, and here you can see the temperature of 25. At the temperature of 25, the value is around 3500. Means if the temperature is around 3000, people are preferring the biking when the temperature is relatively high. Next, here you can see at the solar radiation of 1000, people are significantly increasing the presence of solar radiation, reaching a count of 1000 people are renting the bike at the 1000 value also. Now here you can see the rainfall. Even the rainfall is 20 mm also. People are renting their bike. Now at the commenting about the snowfall, here you can see about the 4 centimeter. For up to 4 centimeter, people are highly renting their bike. But after 4 to 6 year, you can see people are rarely renting a bike after 4 centimeter. Next, about the commenting about the wind speed. If wind speed is 7 meter per second, people are renting a bike at that moment also. Now I plotted the regression plot. So here is, you can see the rainfall. Wait, yeah. So here you can see a plot between rented bike count and rented bike count. It is a linear plot. Next, temperature is positively correlated with the rented bike count. Humidity is negatively correlated. Wind speed is positively correlated with the rented bike count. Visibility is positively correlated. Dew point temperature is correlated positively. Solar radiation is positively correlated, but the rainfall and snowfall is negatively correlated. Here you can see. Next, for the normalization of data. So this is the plot of normalizing the data and detecting the outliers. So what I got from this doing normalization, that no outliers are present in my data after applying the square root method to the rented by columns. Next, finding the correlation between the variables. So I implied here ordinary least square method. Then I assigned my x as a test set and train set, and xy to the train set. Here you can see data frame column rented bike to the y and all other variables to the x. And from here we started to imply the machine learning model. But as already we know that temperature, I found one thing more, that temperature and dew point temperature both are highly correlated with each other. So according to the rule, we have to drop one of the columns. So I decided to do that dew point temperature must be dropped. So I dropped dew point temperature. Here next I plotted the heat map between all the variables. Here you can see solar radiation is rated with the dented count at the 0.26, humidity is solar radiation rated at minus 0.46. Next, these are the variables which are positively correlated: temperature, dew point temperature, solar radiation. Negatively correlated humidity and rainfall. So I dropped down the dew point temperature. Next, what is the information about my data frame? Here you can see that the dew point temperature is dropped. Next, from here, I encoded some part, and from here, I started to apply the machine learning module. So, first module is linear regression. I imported the linear regression from the sklearn linear model. I applied my train set, given all the formulas in the coding, and I got the R square value is 0.77. And in the test set, I got the R square value is 0.78. Then I stored these all values in a data frame for the later comparison at the time of conclusion. This is the residual plot of linear regression. Next, this is the predicted and actual values of linear regression. Next is lasso regression. What I got in the train set, that R square value is 0.40, and in the test set, R square value is 0.38. This is the prediction about lasso regression, and this is the residual plot. Next is ridge regression. So what I got the value about the train set, it is 0.772, and at the test set I got the value 0.78. This is the prediction and actual and predicted plot, and this is the residual plot. Next is elastic net regression, the fourth one. What I got in the train set, the value of R square is 0.626, and next for the test set I got the value of 0.623. Here it is, 0.623. This is the plot about predicted and actual values and the residual plot. Last one is gradient boosting. What I got the R square value for the train set is 0.87. and for the test set 0.86. All the values are near to each other. Next, this is the residual plot. Then the features, I stored all the features in a data frame called importance. So these are the features and these are their importance. Visibility is 00, humidity is 0.13, temperature is 0.32, and these are the sort values. And I plotted these all sort values in a graph like this. Temperature has the highest value function day, yes, humidity like this, and all the other like holiday. And now here visibility, all these values have this zero importance. Next is hyper parameter tuning at the last what I did using grid search CV. So I have chosen the gradient boosting regressive to imply hyper parameter tuning with the grid search CV. So these are my estimators 50, 50, 80, 100. Next 4, 6, 8, 50, 100, 150, 40, 50. Next I printed all the parameters here. My training set. Here you can see. Then I got the value for the R square is 0.95 for the train set, and for the test set it is 0.92, the highest among all my machine learning models. For the train set it is 0.95, for the test set it is 0.92. This is the residual plot, and again I fitted all these things in the importance data frame. So I got the feature importance temperature as the highest and lowest for the R and money. So I want to draw some conclusion basis of my project. So first I did EDA analysis on my project. I found out that rented by count as a dependent variable whose values are depends upon the another independent variables and whose value can be changed from the independent variables. So rented by count are I termed rented by count column as my dependent variable. Then also studied numerical variables, calculated their correlations, distributions, and relationship with the dependent variable. I have removed the dew point temperature column because it has the high correlation between the with the temperature column. And I used 5 machine learning module here. Algorithm here, linear regression, lasso, ridge, elastic net, gradient booster, and at the last I also performed hyperparameter tuning to enhance the performance of our models. So based on all the things, I got the result as this: the training set. Linear regression has the R square value of 0.77. Lasso has the R square value of 0.40. Among all these, highest value has the gradient boosting research of 0.95, and at the test 0.92. And at the least, Lasso has the 0.40 at the training. At the test, Lasso has the least value of 0.38. These are some conclusion which are drawn from the test set and the training set. Like linear regression, ridge regression have the models have the same MAE, mean square error. Next, R square are training and test set. Lasso regression has the highest ME, MSE, and RMSE. Elastic net regression has a similar performance on both training and test set. Next, no overfitting is observed in this data set. Lasso has the higher error and lower R square compared to the other models. So um, these are some conclusions. Like gradient boosting regression has the lower performance than the gradient boosting grid search CV on the training and test set. Overall, at the last, what I want to predict that grading boosting grids a CV model has presented metrics very well. We can deploy this model to this data set. It has predicted the correct situations. So overall, at last, I want to say that all the things which were present in this data set are time dependent, like temperature, wind speed, solar radiation, and may not remain always constant or consistent. They may differ from time to time. So that's why there may be some situation this model may fail or this model may perform well. So that's why as in the field of machine learning it constantly evolves, and we have to up to date up to necessary to stay up to date and require and acquire the latest developments. So this was my project about the bike sharing demand, predicting the bike sharing demand about the rental companies. And I hope you like it. And thank you so much for listening to me patiently. And thank you so much for giving this opportunity to present myself in front of you. Thank you.